next up, From Ember to Inferno, exchanging emails shouldn't lead to complete disaster by November. Enjoy.
All right. Hello all. It's a pleasure being here. It's my first time speaking at BalCCon. So, my name is Nikos. I work as an incident responder for 3 years now. I like forensics, I like petting dogs, I like memes. I'm one of you. So, once I started, let's say, my career back then when I was a student, I always said, you know what, let's make things interesting. And being here makes it truly interesting, to be honest. Yesterday, of course, as you can see, I have a very nice mark from drinking too much rakia, unfortunately. I've been 2 times in Serbia. Last time it ended up with the border patrol searching my crown jewels. And as you can imagine, each time I'm here, something happens. But it's nice. So, what's the agenda for today? We're going to discuss about an incident that happened in an organization. We will not go, let's say, into the details of the impact it caused, because I would like to focus more on the challenges we face and how we will approach, let's say, the investigation. I truly believe that one of the biggest issues at this moment is that everybody can teach forensics, but you cannot teach the investigative mindset. It's something that you either pick it up during with your experience, or unfortunately, it's something that you will need to have talks like that. You have to become better by yourself. And of course, at the end, we will discuss some recommendations on what to focus. So, since the dawn of time, we used pigeons to carry messages. Then we moved on to more electronic ways, let's say. We use the post office services. And then, as you can imagine right now, with the digitalization of all the mailing infrastructure, we use Exchange and, of course, the Outlook. You cannot, of course, have different technologies, but you get the concept, right? Messaging is an important aspect throughout the human history. And today, most of us, most of the talk will focus around the Exchange compromise and Exchange incident. And think about it, that although all these services come together, they're interconnected, and something bad happens to one of them, like in the case of Greece, where it got hacked. The post, one of the services actually got post and said some pretty nice, let's say, message about the Prime Minister. So, what about Microsoft Exchange? The thing is, it is very, very targeted at this point. Since the last 3 years, we had 69 CVs, and actually 10 of them were so big, they had critical score. So you can imagine it was a mess for everybody working in the security industry. It wasn't quite the year that we would hope for, and it involved a lot of incidents. Imagine that when Proxy Logon came out in March 2000, it was in March, I believe, we had so many incidents in only 1 week, more than 4. So you can imagine no sleep at all. But Exchange has a very nice feature. It involves PowerShell that you can have in order to do massive operations. You can do stuff in bulk, you can do things to automate, rather than going behind the console, the web page, and do it manually. Of course, that creates an extra problem for us in the security business, let's say. Because at this point, you had one problem, right? You had to monitor and secure the device, but the server and the application. But right now, with the remote options that you have with Exchange PowerShell, you see how many technologies there are available there. And it's not so easy, because there is one huge problem with security at this point. We tend to limit the usability of our products to enhance, let's say, the security aspect of the organization. And these administration tasks are really important for one organization. Of course, for attackers, this is Christmas, right? Excellent. So, let's discuss about the incident. Pretty much, it involved the typical scoping, let's say, with the client. We pick up the phone, and they give us the first, let's say, details about it. The users inside the organization received a phishing email. It was an email that prompted them to download one malicious file. and they did some basic, let's say, search for the headers in the email, and they identified that the user IP is suspicious because it was not part of the organization. So at first you see, okay, this is a typical business email compromise. No biggie, right? But here's the thing. We received a second call in the next 30 minutes saying, you know what? We have a second incident. So we had 2 of them. At least this is what I thought. So you can imagine it was a very bad day. It involved in 1 week of an incident, so you can imagine there was no sleep at all. But the devil is not black as he is painted, because we have tools, we can detect it, we can respond. And we will discuss during the challenges how tough it is actually. Of course, when we start the investigation, we pick up the web cells. There are at least 3 of them in 2 different servers. And as you can see, it already had systemic privilege, so it was pretty bad from the start. Because at this point, you see that your organization, your mailing infrastructure is completely compromised, and that could stage attacks for the next to enter the other systems as well. It's one thing having a web cell, but it's another to have running it with administrative privileges. Because we were saying, okay, the initial access is on this server. How could did the attackers escalate further? What could they do? We didn't have this kind of visibility. And imagine that in most organizations right now, they don't monitor properly. Not the devices, not the systems, they don't know what they have. This is a big, big issue when it comes to scoping the incident. Because most of the times you enter blind, you don't know where to go, where to look, and you have to pick up, let's say, some needles inside the whole haystack. So, once investigating the ISS logs, we could find indeed that these web cells were prompting for some queries back to the C2 channel. And these are very important, keep them in mind. This is where you should be looking once you have a compromise like that. Not necessarily from Exchange, because IIS might have different applications running on it as well. So the ISS logs are very important for us. Always keep them safe. And if you can have a good retainment of at least 1 month before, I say the least, because it should be the bare minimum. Most organizations don't have this type of logging capacities. Most of the times we have the question, okay, what would be a good retainment? And most of the times it involves the cost of the organization, because logging and storing it costs. So a good idea is to have at least 3 to 6 months of retention. As you can see in the web cell, in one of them, the attackers were exchanging the local seeds, and it was a base 64 string. So always keep in mind that, okay, you see something that you might not recognize at first, but always look at patterns. And then we focused on the Exchange server again. As you can see, we found out in GitHub with a simple search that it was not even, let's say, a very, very difficult attack to identify at first. It was just a public POC that was out there and was run by ScriptKiddie. Imagine that when a proxy cell happened, when it came out, it was, I think, August. And this incident was in November. So the organization should have already been prepared for that, but they didn't. And this goes to show that no one cares about the patches, that even the most simplistic attacks can be done. And I'm saying simplistic because a public POC that has already been picked up by antivirus, by DRs, by whatever, may be able to stop it. And most of the times, I see organizations saying, okay, we need to invest more in EDR, we need to invest more in the detection capability. The thing is that all of these products will be bypassed at some point, right? So no matter how you invest on the detection side, you should always invest on the response as well. We should, it's something that I always say, that there are 3 things in life anymore that are inevitable. It's death, taxes, and cyber incidents. And we will never be able to avoid them at this point, unless nuclear disaster happens and we're out of electricity, and then we will not have the systems. But always, 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 keep in mind when you're looking at your logs, you might be able to find unique identifiable observables, as we call them. In this case, it was this user agent. Because once I started investigating, I said, okay, we have two incidents right now. We have the one with the business email compromise, and we're having one with the exchange. Do they have some sort of collaboration between them, the attackers? Did they know something? Is it part of the same attack? Is it something new? To be honest with you, it was my most difficult incident, because it took me at least 3 days to try and pick up what actually happened. And imagine that it's not always easy when you have an investigation, because it's not always linear, right? You pick up some traces, you pick some evidence, you investigate as you go. And then you have to do the analysis. But at the same time, you run out of time. Because most of the times the organization says, okay, you know what? You do a very good job with the forensics, but I need to go back in business. Yes, but how can you go back to business if you don't know where the incident happened? What happened? What caused? What was the root cause of that? What would you do to stop it from happening again? Most of the times that we see in ransomware cases, everybody proceeds to recover, but do you know the entry point? And if your backups are already compromised, if you install the systems from scratch, again, what would happen? Nobody actually thinks about that during recovery times. And this is something that we should strive as an industry to see what we would be doing. Because at some point, we see that most of the times, the response companies that they called, they only do basic investigation, let's say. And they proceed to according to the client needs, and because you do what your client pays you to do, you say, okay, I will stop my investigation, I have already billed you, and I will continue with the restoration of your services. The good thing with forensics is that it's a very well-established science. We do have this principle, as we call it. It's the Lockhart principle. It means that at all times when a crime happens, traces will be left behind. And this is true to cyber incidents as well. And no matter what, something will be there. Remember when I told you that it was so difficult to try and understand if these incidents were linked together? Well, in fact, they were. And I was amazed at the end of it, like, wow, I couldn't be able to understand it. But again, as you investigate, you get all the pieces together. So one of the conclusions that I got out of it is never rush to judging the situation initially. So these are 3 things, let's say, on the exchange technology, how it works, because it's one thing to receive the email in the server, and it's another to have it in your system, right? So you have the message tracking, you have the swap request, the swap messages we call it, and you have the authentication. As you understand, the authentication means identity, it means user, it means an account. And as we talk about NTLM, you can figure out that if you can have a compromise, and if you're able to hit the exchange initially, this is a very good starting point. Because as we saw, the websites were running on system, so you would have escalated privilege already. And getting a hash would be very, very good to actually propagate inside the organization. So just to have a graphical picture, this is from the Microsoft website. You will be able to understand, let's say, a little bit better. We mostly thought, it flickers a bit anyway. But as you can see on the auto-discover service, it is the first that got hit, and then it escalated to EWS service. So what was the anatomy behind the attack? The auto-discover service is abused to leak the distinguished name of a known user. In this case, it was the administrator. And keep in mind that it is a very nice recommendation to change the name of your local administrator or disable it, one of those 2 things. Because even a script kiddie, even someone that has low, let's say, capacity and doesn't know your organization, they will always try the first admin or administrator, something like that. And for them, it was the case as well. So the attacker knows the most well-known distinguished name. and then they can forge their access to the AWS. So with the attacker being able to successfully impersonate the target user with this valid access, they can perform all the AWS operations they want. So the proxy shell, to continue the operation, they will have, let's say, the swap request we're discussing. So one of them was a create item. So it allows the remote creation of emails, and then they can impersonate the user. Imagine that this was the missing key, because we were looking at the web shells, we were looking at the emails, we found that in the mailbox, we analyzed the headers, and I found out actually that the client IP address, the one that sent the email, was the one that had performed the swap request, the swap action, the create item. So this was the missing link that we require to, let's say, link the attacks together. When proxy shell happened, I'm like, oh my God, finally I'm looking at an ATP. Finally, I'm a proper responder. But it was not the case. I asked to judge, and this was a mistake from my side, because you go to the client and say, you know what, you're being targeted by the Chinese. And they look at them, oh my, why? And this causes an unnecessary escalation, let's say. So that's why I say I have to be more careful next time. But I'm happy because I learned from my mistakes, and this was a key. Because it took me like 3 days only to find this IP address. And I found out from the create item. To be honest with you, I didn't have much experience back then with Exchange, but as I told you, you learn as you go. You can't learn all the things, right? And this is a very big statement when it comes to most response companies and all the response consultants out there. If you don't have the capacity, you don't have the knowledge inside your organization, you will probably outsource it. So you cannot expect everybody, let's say, to have the knowledge on all technologies. Technology evolves so much right now. Imagine that in cloud, especially in Azure, things change. It's 6 months. So you either have to keep up, or you will have, let's say, this sort of slacking. And this slacking can be a little bit dangerous. Imagine that with the forensic tools as well, they don't have the latest kernels inside them. Because first you wait for the OS to come out. For example, in volatility, we didn't have the latest version to analyze the Windows 11 systems that were out there. So you can imagine that this can create a problem as well. So this would be the bigger picture. Let's say this would be how we link together all these incidents together. It was not 2 incidents actually. As you can see, yeah. We had the proxy exploitation, the proxy shell exploitation, and then the attacker created the swap action. This is how you were able to transmit the message. This is how the attacker would spawn later the attack. It was, if I remember correctly, it was the squirrel waffle payload, and it didn't cause that much trouble inside the organization. The good thing is, because they detected the Exchange compromise, they were so agitated by that. So they were behind the screens all the time saying, okay, what happens now, what happens now? And they were asking questions to the users. And this is a bad thing, because when you don't have consolidated logs, you only require on the users themselves to verify if they clicked or not. And we will discuss about it in a few seconds. So additional investigation always evolves around the processes, right? It's really, really important to understand what processes are being run, all the volatile information out there. So this is why you should never, ever shut down a system. It's better to just disconnect the Ethernet cable or disconnect from Wi-Fi, because all the volatile data would be lost. Imagine that we are seeing power commands from W3, WP, and we would be able to see from telemetry, we would be able to see the malicious commands from the attackers. This is how you properly do the scoping, because imagine you can see that the command get mailbox, for example. It means that right now the attacker has knowledge of the emails that you have sent. Right now they know more people inside your organization, and they can stage more attacks. I believe that with all the evidence around, you would be able to have better mitigation action, let's say. Because it's one thing changing the password, it's one thing, let's say, reissuing Kerberos tickets and even certificates. So once you finish the investigation, then you would be able to say the impact. Remember, there is no one-size-fits-all solution to that. And this is why we shouldn't just rely on password changing. And what I loved about the latest technology right now that Microsoft offers, it's by no means there's no sales talk, but as far as I know, they are the only detection action at this point, the 365 Defender, that you can have telemetry, especially for clicks. So with this query in KQL, you can actually find the list of all the users that they have clicked the suspicious links, let's say. And as you can understand, it's very good for us, because at this previously, we had to go to each computer that we assumed it was breached. And then we had to perform forensics and do all the actions there. Imagine that there is a specific key registry where you have to investigate to find if a user has opened an Outlook attachment and an Outlook link. But right now, with telemetry, we are more able to stop, let's say, the incidents before they cause too much trouble. Because indeed, a business email compromise shouldn't lead to a complete disaster. This is the time where you actually take your phones to take photos. I've consolidated all the things we did for the investigation. So always, processes. It's very, very important to see for shell commands. It is also very, very important to have all the volatile data. I'm saying process because most of these times, at least in the investigation, the whole incident evolved around the compromised web cells from the compromised server. So keep in mind also that you might have web cells. These paths are indicative. Most of the times they might actually change, but these are the two paths that are actually writable. But keep in mind that that's why I put the asterisk on top of that. They might be somewhere else. Of course, you use the application logs as well, so it's really, really important not only to gather the logs from your system, but from the applications as well. And this is a general recommendation, not just for Exchange server, not just for ISS logs, call it whatever you like. We had an incident last week where it was an unauthorized access into a server, and their client goes and says, okay, can you please tell us if we are compromised? And we go, okay, of course, but do you have application logs to tell you which accounts actually logged in? And said, we don't have that kind of visibility. So, because all the external facing applications on your organization will be targeted, let's face it. You might have, let's say, a lot of false positives. You will be seeing scanners, you will be seeing script kiddies, stuff like that. So we typically say in the business the words maturity, but what does it actually mean? It's a big buzzword, right? We only care, let's say, how much someone will invest. And without proper investing, that's true, without proper investing in firewalls, in all the proper detection techniques, it is very hard to respond. Very hard to respond. So let's discuss some of the caveats, some of the problems that we face. The one thing that most of the times we do as a response consultants, and call it whatever you like, blue teams, defense teams, whatever, we link everything to Mitre attack. That's good. Mitre has already provided a good consolidated list. You have a very good picture, let's say, of what can be categorized as a tactic, as a technique, as a procedure of the attacker. But it's no silver bullet. So this is why Defend is being created at this point, because all these tactics, all these techniques would produce artifacts. And as you can understand, you have multiple tactics and procedures that map to specific logs. Keep in mind that first you have the system, then you have the attack, right? Someone has to happen. So we need to know our operating systems better. We need to know our applications better. And I believe that this is what Defense strives for. If you don't know it, give it a look. I believe the combination of both frameworks is really important to shape the future of cybersecurity, because things evolve and we cannot rely not only on a single framework. We need a combination of them and a combination of different skill sets. I don't like putting hats, saying gray hat, black hat, white hat, or even saying blue team or red team. Security is one, right? So we should be able to collaborate better. And frameworks like them that enhance the collaboration, I believe this is what we would be striving for. And these are some of the challenges, of course, that we face. Like I told you, you have to know your logs. You have to. It's something so. This is why I laugh. It's something that most organizations don't put focus on, and not having logs is essential. You cannot expect not to have an incident. At some point, you need to realize that your digital footprint is out there, and you have to do something about it. You may not have, let's say, the biggest investments when it comes to detection capabilities, but you need to be able to respond and respond fast. The investigation, as I told you, is never linear. You pick some trails, crumble, stuff like that, and then you start connecting the dots. Like I told you, I jumped too early on my conclusions. I try not to do that anymore. You learn as you go. Something that is very important as well is that you don't understand the pressure that a response team faces actually. Because you wait your normal 8 hours, let's say, and then you get a call on your Friday night and say, okay, you know what? Screw your weekend. You have to respond. You have to go to an organization. And this creates an extra pressure. And especially during COVID times, this is something that creates a lot of stress during, not only for responders, but I believe, most of us. Of course, sharing is caring, right? This is why we need to have conferences like that, open conferences. We need to have open resources for digital forensics as well. And what I don't like particularly in this industry, in the FIR, is that there are not known, let's say, many resources out there. You have to either pay for them, or most of the times, as they say, you can play in CTF, stuff like that. I don't really believe that CTF approach is better for forensics. Because imagine, no one teaches you how to search the needle in the haystack. But when you're playing a CTF and you're hunting for the flag, you're focused on only one mission, finding the flag. You know it's there. Sometimes when we get called to respond to incidents, they are not even incidents. So imagine you have to image the whole computer just to find out in the end of the day that nothing happened. But you have to be able to prove it. And that's why I say forensic is science, hacking is an art. And you have to properly have a structure behind that. And just by playing, you cannot be able to get, let's say, the bigger picture in the future. And that concludes my talk. I don't know if you have any questions. Yes.
Hi, thank you for your presentation. I was wondering, you said that you matched your malicious SOAP API request with the IP address of the sender of the email.
Yes.
But if I'm not mistaken, the IP address of the sender is usually the SMTP address, the server SMTP address. So did you manage to find the IP from an administrative console of the user that actually sent the email?
Here's the thing. This investigation specific to this point, you had to do it in Outlook. This is why I was talking about the headers. We found the client IP address. This is the one that matches in the headers. And then you find the IP address in the logs. Imagine in the logs of the system it was the AWS. We can go there. So we knew the IP address from the client is in the middle. We found that in Outlook. With the email analysis, right? And then we jumped on the server, and we're going through all the logs. There are so many logs out there. And at some point, I started investigating the user agent that we saw previously from the attack. And all of the time, it appeared that all the requests were done with this agent. Because imagine next slide, yeah, we had two infrastructure set up by the attacker, but the emails were sent by this one. So this is how I was able to pinpoint, let's say, that these incidents are actually together, they're linked together.
So you match the IP address and the user agent together?
Yes.
For this incident?
It sounds funny because it's so simple, right? Because you look at a user agent and say, okay, these things match. But initially, because we didn't have the visibility that we wanted to, we didn't know what was happening inside the organization. So that's why we thought it was two different incidents. And these two things actually proved it was one. And the mitigation actions behind that are completely different, as you can imagine. Business email compromise from a whole domain recovery.
Okay, thank you.
Did you sleep during the incident response?
No, unfortunately, no. I didn't sleep last night as well, so you can imagine that my whole life is without sleep.
You should sleep more.
I can sleep when I die, that's what I say to myself. I almost died yesterday, but that's a different story. Yeah, I believe that concludes. Oh.
I have one last question. What is, in your opinion, the best size for an incident response team for an investigation?
For the investigation, I wouldn't say about how many people you need. I would say which roles you need. You definitely need someone to speak to the client, an engagement manager, call him whatever you like. And then you need to have at least 1 or 2 responders. You will be amazed how much overhead is created once you investigate, because the clients ask questions all the time. What are you doing? What's your status? What's your progress? Stuff like that. So you need to have someone in the between that manages the client expectations. It's really important as well. That is important as well. But I would, ideally, it would be, let's say, 3 to 4 minimum. And of course, that depends on the size of the organization. The roles. Yeah, you have the responders.
The roles. I mean, you have someone who's going to be speaking, and the ones that are going to be like on the technical side, what should they be? What should they?
A logic size, that's why I say 3 persons at least, because then you put extra cost, the utilization aspect, all that stuff. You need definitely someone to be in the between the client. But when you say that you have 3 extra persons, let's say, you need to have different skill sets. Not all of them should know, for example, Windows. Someone has to know how to image and do Linux forensics. Someone has to know how to do cloud investigation. And this is how, actually, this is like the concept of the red team, right? Of the red teamers, the attackers. No one knows everything there. So why not have the same concept in forensics? Everybody expects you to know everything in this field, unfortunately. And that's not the case. That's why we need to collaborate more. Yep, that concludes the talk. Thank you very much.